All right, the other thing I wanted to unbox right away is the eWay, because the eForce needs an eWay. This is a wireway, a gutter, a raceway. It is a way to collect up all of the batteries into the circuit with a bus bar and an enclosure and a way to distribute the power from the batteries. This is this converts, I'm going to say this several times, but with this setup, and here is the mounting template. You see an actual full-size template, real nice. So with instructions or holes for the different inverters that you might have fitted here, if you're wall mounting or floor mounting. This makes this so easy for DIY. And you know, if you're a professional installer of stuff, why wouldn't you also want the easy button? I mean, this makes total sense. I don't want to mess around with a tape measure and calculate some stuff. Do the procedure, slap this on the wall, mark it with the Sharpie. That's where it goes. You don't have to, like, you know, guess. This right here makes a solar power system more like an appliance. And that's the goal here. You'll see as I go along, I will keep saying this is an appliance. It's going to be a lot easier to install. So let's get into it. First of all, I don't want to lose this. This should be painted gold, but I'll put it here. Okay, data cables. Start to see what I'm looking for here. Look at this. It's got a display that shows the battery status of the batteries, and it has the traditional switch on and off. And I'm going to use some of these knockouts on the side. You can't see. We'll get this out of here and let's see what happens, how we're going to lay this out. All right, here is the first view of the eWay. You can see that there's the top part and the bottom part. I'll separate them in a second and we'll show another section of this. There's a door on the front with a key, which is in the bag there. There's knockouts on the top here. This, I think this entire plate gets removed for the inverter, so you don't have to actually use the individual knockouts, but you can. On this side, we have additional knockouts for the side exits. Here's the seismic plate that was in the battery. So basically, you stack the batteries and you install the seismic plate there. That just keeps things from going up and down or left or right if you have a seismic event. Here's the key I referred to earlier. The data cables I mentioned. There's a little bit of knockouts on the back, just in case. And I need knockouts on the side over here, which I do have. So I need to get my grid power inputs and my load power out in there. And then of course earth ground. So yeah, this is nice. Let me get that key out, open the door, separate these two, and then you can see how this will go together. All right, I didn't mention earlier, but there is obviously a complete manual. And one thing I want to point out is in the manual, you'll have IKEA style guides. Get screw A, put it in so-and-so, and get bolt F, and C, and B. I like this a lot because not everyone knows this is an M5. Is that what this is? See, I don't even know. M5? Maybe M4. Whatever. The feet go in the base. If you're going to level it on the floor, I'm going to use the feet, of course. I like to have that extra height. The feet will screw in those holes and help you level the bottom tray to the ground. In case your floor is not perfectly level or flat, you can fix that. So this is the bottom. Here's your course guide pins for putting a battery on top. And here's your pogo stack. This has, I'm sure this is a pogo stack for power and ground, but this one is empty in the power side here because this is the base. But this says I'm the bottom. I'm sure those pins are I'm the bottom. It's a strange airplane flying over. Might be that guy with that helio thingy that he's got. This is the top box, the eWay. And so I got the key, unlocked the door. See, it's hidden. This is not really a fingerprint reader, but if you touch here, it's a wake up to get the screen to wake up. Then inside, which is what I like, look at this. You have bus bars sufficient to hook all the batteries up from the battery stack into the inverter. And you have comms, and you have a Guardian. So that puts your whole system on the internet where you can read the batteries and the inverter status. And then of course the on and off switch backside there shows you this has a rapid shutdown switch built in. So I'm going to, oh, the Wi-Fi antenna goes out the back. I can see the coaxial cable there. That's located there in that bag. All right, great. So, all right, this is real nice. And I see, I didn't see it before, but there's a prop bracket. So I can actually prop this lid open and not have to hold on to it. And then of course the electronics for the display are there, and some other connections. All right, this is very nice. This is gonna make DIY easy. So D-I-Y-E, I don't know how you pronounce that in English, but that's how it's gonna be. Put that last foot in. One of them was a little tighter than the other one thread-wise. No big deal. So now let's take this base over. We're doing this live, people. Okay, this is the bottom of the foyer of my shipping container office. There's the base. Now, we've got this base set up. It's gonna be nice. I really like the way this goes together. This is different. Some batteries, some of those large batteries just have the base kind of built in the feet. You got all that weight on the feet. You can't really adjust them that well with the weight. So the question now is, how level should we level this leveling device? We've got 3 different levels here. We got the 30-year-old Craftsman. That looks almost level. I need to turn it some. We've got your Husky. It says 0.5 degrees high on the right. Let's get a real level involved. Oh yeah. Yeah, this thing, I think this thing counts the rotation of the earth in its level. Not sure, but that's legit, okay? So obviously I need to go up on the left slightly, and I can do that easily because I can actually just pick up the base, rotate the leveling feet, get the number I'm looking for, and call it. There's several different layouts that you can make for this product, and we're gonna do option 1, 2 batteries in a stack, 20 kilowatt hours. Well, technically 19.2. So this system is replacing or moving around 4 eFlex 5.4 batteries. I'm going to move those 4 to the main group of them. And then 2 stack of eForce, 1 NV inverter. That's my plan. So there's different layouts here you could pick, like mount everything to the wall, mount it to the floor. Actually, I guess technically it's option 3 since I don't have the that cover. Didn't think about that cover. I don't know if I need it, but I might. Oh yeah, that's for more outdoor. This is for less outdoor. This is what I have. My container has doors that I can close. You know, I might get that. Anyway, I digress. Let's get over to the section where this is what I wanted to show you next. Maybe use this. Oh, this is hard with the wind blowing in one hand. What happens here? This is what I'm doing now. I got the feet installed. I'm going to mount these brackets. These brackets set, here's the bracket right here. This is nice There's another battery where you have to have non-combustible material, or you have to make a 2-inch gap. Well, Fortress made the 2-inch gap for you. This is probably more than 2 inches, but it's about 2 inches. So then this automatically sets the gap between the batteries and the wall. That way you don't have to mess with that part of it. So I'm going to install these on that base. There's 2 of them. And I also know that there's 2 of these for each battery. So basically the battery will sit on the base first, and then on the next battery. And then you secure them to the wall. That gives you your anti-seismic activity bracketing. In combination with this item, you get anti-seismic activity, whatever you want to call it, remediation. Or it's not even remediation, it's preventing in the first place. So, anyway, my engineer brain's thinking about all this. So then I'm going to put the base in first. Then I'm going to get this template going. This is I guess this may be my favorite part of it, even though I did say that the naming the bags was my favorite. Look, just soak that in for a minute. You have a template that actually matches the situation. 2 batteries, and then move the template up for the inverter. I'm looking forward to this. All right, here we are. We're on this page. We've got the base on the ground leveled. Then it says use screw C or D. Here's screw C. There's C. And D is the concrete anchors. We have a plywood wall, so we don't need concrete anchors. Put those with the rest of the pile of those. Now, alternatively, I could use a shorter screw if I needed to. Here's a 5. This is roughly 5/16, and because it's metric, I'm sure. Then here's a 5/16 1.5 inch, which I could use. And then I've also used the GRK structural screws, 1/4 inch by 1.5 inch. Therefore, I will just use the original screw that came with the battery. This extra penetration won't matter because this wall is insulated, but there's nothing there wire-wise. And I will double check that. I always run my Romex horizontal at 24 inches. I will measure to make sure that the next battery does not occupy the 24-inch zone, so that when I put the next battery's brackets, I don't go deeper than I should in the 2x4 to get to the wire zone. So that's just a little measurement. And if I think I'm going to, then I'll use a shorter screw. I have 5/16 even shorter than 1.5 inch. We're just preventing the battery from tilting over under some conditions which we can't foresee. And now, for what I said was going to be my favorite part. Zoop, the wall template. I have lowered the template to this battery and that one. And I knocked out the little pre-knocked out holes. See, there's the 8K pre-knockout hole. Right? So I've got the 12K. Keep this template down exactly. Use a Sharpie and just circle my hole. And then get that one. Okay, yeah. It's barely gonna I can barely reach up there without a ladder, but I can. So, yeah. All right, get that one. Get that one. Come on, you can do it. Okay, yeah. Now, that one and that one. All right, I'm gonna make custom battery cables between the eForce and the NV12K. So, bill of materials, sockets, torque wrench. I have some leftover cables already. I'll get you this measurement here in a second. And wire cutters, ferrules for the ends, and of course, a la manuelle. So, let's go put a cable inside the inverter between the eWay and the inverter and mark the length, cut them, install the ferrules, install the cables, tighten everything up. All right, let's do it. Stand by. All right, this is pretty straightforward. I removed the 2 plates between the eWay and the inverter, and so it's just like drop the cable in there and temporarily install it on the bolt. Maybe I'll choose the bottom pair to make them the same length. Stand by. Like that. Have to get it to go there. I will. And then align it with the entrance, and then mark the cable where I should cut it with just a little bit of extra, just a ½ inch or more, and then strip it back. All right, let's do that. All right, I've got the battery cables made. You can see that they are tightened. I made sure that these are also tight over here, these screws, just to make sure. Also, another tip, I loosened all of these up first so that this plate could move up and down to allow the screws to go in nicely. Same for the back one. Loosen them all up. The plate will wiggle, and then you can get the bolts to start. The holes are just the right size, and there's a little compliance there. So, and then ferrules are installed on the upper cables and lugs on the bottom cables. All right, the bottom of the cables. Here's what I come up with for size. Set that, set that there. There we go. You can see, I'll make this a little bit better, but here we go. Battery cable, the red one is 21 inches, and the black one is 15.5 inches. That's from the end of the cable to the center of the eyelet. So plan accordingly. The cable has enough room to, you know, be adjustable, and also, bloop, out of the way. I can get to the PE bus bar in the back just fine. All right, there's that. Next step. All right, down below we have 2 data cables to plug in. One comes with the Guardian. It's already wired in. It's the green cable. It's wired there for communication to the Guardian. The second one is the orange cable, and that goes to RS485/CAN of the BMU, I guess you'd call that. The batteries have BMSs, and so I guess that's the BMU because it has communication and I/O, and it operates the display, which is here. Boop, see, Mr. Display. I'll explain the display in a second. Oh yeah, so there's the 2 cables. Orange, well there's 3. I'll talk about the third one. There's a rapid shutdown switch, so I've connected the rapid shutdown down here. Then up here, we have a home for the Guardian to go in that communication cable. It's an inverter output of 485. The inverter's output of 485. And then we have the orange cable right here, goes into an adapter, because this is the G3 version of this inverter. And one of the things is G3 means they must have changed the pin out of this connector. So they made this adapter so they can use the same orange cable. Yeah. Oh yeah, and then the rapid shutdown goes into the rapid shutdown port, which used to have a red jumper there. Another cable I plugged in, which is not part of the eWay, but I plugged in, is the CTs, current transducers. I put them here on my loads. I mean my grid connection, so I can measure my local loads. In the future, I would like to pull a 285-foot cable all the way to the meter. Well, that's the future. There's a 2-inch pipe, but I'm going to have to get a shielded cable. Well, anyway, that's too hard to think about right now. All right. Let's talk about the display on the eWay. Now, you may notice this is the Fortress Power logo. So sweet that they integrated the logo into the display. First of all, let's talk in descending order from 8 to 1. LED number 8, which is this bar, indicates if it's on, if the LED is on, the eWay is on. If it's blinking right here, then it's over temperature, overcharge, over temperature, under temperature, alarm, I guess you'd say. And then if it's in the discharge mode, it's also an alarm of this kind, over temperature, over current. LED number 7, which is basically addressing and communication. If it's correct, it's on. LED number 6, if this box is on, then also assigned to addressing and communication. And then 5, 4, 3, 2, 1 are the state of charge. 5 is completely full, which it says here 95% full. I have mine programmed to be about 80% or 90. I think it's 90 actually. I see it running around 88%, so it must be the target of 90. That's 4. And then 3, LED 3, 50 to 75, LED 2, LED 2, here we go, 50 to 25, 25 to 50, and LED 1, 0 to 25. Now, if it's blinking quickly, it's charging, and if it's blinking slowly or flashing slowly, it's discharging. So this error message here is a slow blink right here. This error message column is a slow blink on the big bar. Now let's look at it. This won't work, but this will. Beep. So you can see I'm on. I've got communication, the 7, 7, and 6. That's my communication status. And then I'm, 4/5 of the way full. It only stays on for like 30 seconds. Now, I'll give you some updates here. I like the logo display. I think it's nice. I would prefer having some numbers, or the ability to set some numbers, or some color. Maybe that would be good. Also, to have it 3 modes. On, dimly on, or noticeable without consuming backlighting, and then off. And of course, I know I can get numbers from the actual inverter display there, but this is a nice display. So I like it. And once you get used to it, you understand what you're looking for here. Your battery indicator is going to be simple. If you've got your boxes lit up, everything's fine. If something's missing, if this one is blinking right here, it's got problems. So I like it. And that is the long summary of a short item. And from that standpoint, I love how all this came together, and the eWay is like the critical component that makes it very simple to put together. So with that, I appreciate you watching. See you on the next one.